Okay, dear students, so welcome to this video. And in this video, we are going to learn about the energies in gravitational fields. How are they, how do we work around with the energies now? So it's a bit confusing, but not that difficult. So be very careful and you can learn each and everything. Now, listen to this. Whenever we are considering some astronomical object like planet or a star like sun, so there are two types of motions that we will be concerned with. The first motion is that there are, like, you're just talking about the two positions, like this is the first position, this is the second position in the space somewhere, and the bodies are either going away from the body or they're going towards the astronomical body. Distance is either increasing or decreasing, like that. There is another type of motion which is very popular in gravitation, and that is satellite's motion. Now, this object here is not a satellite, and that is why it is not revolving around the astronomical object. It might go in this way as a satellite, and it might start revolving around the another astronomical body. Now, that is called satellite motion. We are not considering that satellite motion as of now. We would be doing it in coming time, but not now. So in this video we are going to consider only one type of motion, that there are two objects, like there are the two positions, the object is changing from one position to the another position. First of all, this. So we have this is the first point, that we are only concerned with an object which is changing its position from point 1 to point 2, and it is not revolving around the astronomical object. Point number two that we have to consider here is, in these kind of situations, we do not consider kinetic energy. So kinetic energy is not considered, or we can say that there is no change in kinetic energy. So it was earlier, it was not moving, the velocity was zero, and at the final position also it was not moving, and at that time also it was zero. Or we can say it was moving with certain velocity, there was a constant velocity throughout the journey, there was no change in velocity, neither increasing nor decreasing, because we just want to make our calculation simple and we do not want to incorporate another type of energy. That is why we assume that there is no change in kinetic energy. Now, point number three that I want to bring here is, total energy is the sum total of potential and kinetic, but kinetic energy is not considered in this scenario. And that is why we will say that whenever we say the total change in total energy, we are always referring to the change in potential energy only. So you say the change in total energy, which is actually equal to the total change in potential energy. There is no difference between total energy and potential energy, because we are not considering kinetic energy. Now, having said that, let us move to the next part now. Now, we are going to learn only and only about potential energy in this, and specifically it is gravitational potential energy. So it's very different, and every different kind of potential energy is having different kind of features. Like potential energy, elastic potential energy in the case of spring is completely different. You know, everywhere you will find potential energy to be different. Electrostatic potential energy is again completely different. In this case, gravitation is only and only attractive forces, the only attractive forces. And whenever there are only attractive forces, the potential energy is always considered to be negative. So the first thing that you need to understand here is, potential energy is taken to be zero at infinity. This is a reference point which can be otherwise also. You can choose it to be zero at the surface of the earth also, but our scientists, they thought that no, it will be better if we take infinite distance to be zero potential energy. So at this point we choose potential energy to be zero, and after that they are attracting the body. So closer this mass is to the other mass, they start attracting each other. So there is attraction now. So there is a big question. Listen to this. Let's say I'm talking about this position and there is the body here, and it is not moving, and we are holding these two masses together like this. They are not moving. There is no kinetic energy, nothing here. But as long as I leave this, the mass starts moving towards the astronomical body because of gravitation. It means it is now gaining kinetic energy. It is gaining velocity. It is now moving. It started moving now. So the question is, energy cannot be created nor destroyed. So from where is this energy coming? So this answer was given by the scientists by saying this, that the potential energy here is not zero. It is only zero at infinity, because if you do the same thing when the bodies are at infinite distance, this body is not going to move towards this, because these bodies are not interacting at that time. When these two bodies are at infinite distance from each other, they are not interacting with each other. There is no attraction at all. So when I leave that body at infinite distance, the body does not move towards the astronomical body. It is not moving. It means there is no kinetic energy conversion. It means there was no initial energy. So we can just say that the potential energy at that time was zero. Kinetic, we are not considering, it was zero. It means that total energy at infinite distance is zero. So obviously energy cannot be created nor destroyed. So it will remain at that point. So this position is zero. But when it is coming at this point, there has to be some potential energy which is getting converted into kinetic. So this explains why the potential energy here is taken to be zero. And when you keep on moving towards the astronomical object, the potential energy starts becoming more and more negative. So you can clearly see, like, if these are the distances that that body is moving, like this, so the potential energy keeps on becoming more and more negative. At this point it is zero. At this, I'm just taking example, -10, -20, -30, -40. Let's say here it is -50. Obviously these are just example, this is just example that I'm taking. It is never like that, like these are very simple values that I'm choosing. So it is zero at infinity, and closer you come to an astronomical body, the potential energy start becoming negative. What is the formula for the potential energy? The formula for potential energy, it can be derived with a derivation, but that is not in our syllabus, and I don't think that we need it. That is why I'm not giving you the derivation here. In coming time, if I feel that yes, the derivation is important, you need it, I will be creating another video. Don't worry about that. Till now, I am not giving you the derivation. So the gravitational potential energy is given by the formula G, product of the two masses divided by the distance between the centers of the two bodies. So this body is having a center here, and this body is also having a center here. In some other videos, in the last video, I told you gravitational forces are central forces. That is why we are only concerned with center to center distance. So this is the gravitational potential energy. What is the gravitational force formula, by the way? It is taken to be positive, although the attractive forces are also negative. It should be taken as negative, but in our books, whenever we talk about force, we only concern ourselves with the magnitude. So that is why we don't use the negative in front of that. But technically speaking, attractive force is negative, repulsive force is positive. So you should be using a negative sign here. But I am not using it because that is not given in our books and it is not required. So be careful. So this is G M M divided by R square. In my private classes, I have seen many students getting confused. When are we using R square in the denominator and when are we using R in the denominator? That is why I want to make it clear at this moment itself. For force, you are having R square in the denominator. For potential energy, it is only R. And force will be, we are not taking it as negative, but gravitational forces, gravitational potential energy is always taken to be negative without fail. So it is always negative, which is this. So lesser is the distance, more becomes the magnitude, and it becomes more negative. So closer you are, it is becoming more and more negative. This is gravitational potential energy for you people. Nothing much to note in this. Now, I would be moving into another thing, and that is gravitational potential, and we are going to do that in our next video so as to avoid the confusion between what is potential energy and what is potential. Okay, dear students, thanks for watching. Thanks for joining the YouTube channel. All the best. Bye.